Hello, welcome back to my video. Um, I forgot how many videos I recorded, so anyhow, welcome back. So in this video, I'm going to show you um, a real data example, that contains multiple variables, and we will study how we can analyze such a data. And this data, this is a screen capture of the Excel file of the data set. I'm going to upload this Excel file with the slide and the video. So you can open the Excel file and look at what's going on. The content is not of our interest. We will look at the structure of the data and how to understand the data set. The source of this data set is NLSY. It stands for U.S. National Longitudinal Study of Youth 1997. So in this data set, in this spreadsheet, there are many variables. It is easy to understand, like gender, female or male, birth year, and race, region of residence, education, marital status, employment status, health insurance coverage. And each row has one person. So the first person is a female, born in 81 and non-black, non-Hispanic, living in Northeast, finished 12 years schooling and never married and employed but has no health insurance. So you can see information of a person in each row. And it does not contain all the data. The full data set I have has more than 7,000 individuals. Let me briefly describe what the data set is. So NLSY is collected every year from 97. It is still being published every year. And what they do is in 97, they choose a certain number of people, random people, and they interview those people every year. Those same people are interviewed every year, and the data I show you is the 2006 interview in 2006. So you may compare how their life cycle changed, or when they changed their job and when they lost their job, and other many things. So that's just the background knowledge of the data set. And in this data set, you have to, when you read this data set, you have to think about the underlying experiment and the population. First, the population is those who were born between 1980 and 1984. The main purpose of this data set is to record uh, those guys' life cycle changes, lifetime changes. So, like they choose a certain cohort and follow them very closely over a year. And the sample size, our sample is the data. So the population is everybody in the United States born in 1980 and 84. But in our sample, I don't know how many population satisfy this criteria, but does not matter. Anyhow, we do not know them, and we assume there are infinite number of people like them. But on the other hand, our observations consist of uh, 700 and 154 individuals, 7,154 individuals, after removing missing values. So missing values may arise by mistake, or if they do not participate in the interview, or simply they may not answer something, they may reject to answer some questions. So after deleting those kind of irregular answers, I have a clean data set of 7,100 people. So then, given that we want to study this population, and the experiment behind this data set is to choose random people born in 80 and 84. So they are our population. So randomly choose someone from the population and then ask 8 questions. Actually, in the real data set, there are more than 8 questions. There are hundreds of questions, but I only take 8 typical important questions, and let's just say there are 8 questions, and that is one experiment. So one experiment is, again, choose a person, random person from the population, and ask 8 questions. Then from one experiment, you get 8 answers. That is one experiment. So the number of questions is exactly the number of variables we have, and the number of variables do not affect the sample size. The sample size was the uh, number of repetitions of the experiment. In this case, even if you do the experiment once, just you will get many numbers, as many as variables. So number of variables has nothing to do with the repetitions, so it has nothing to do with sample size, right? So having more variables will help. It contains more information, but it does not improve the accuracy of the analysis. The accuracy of the analysis, it depends on the sample size, not the number of variables. And so then now, if you understand the underlying experiment, then it is easy. Just one row is one experiment, right? If you do one experiment, you have one person, and then you get one row, like 8 answers. And each column is one variable, which is one question in the survey. So that's how you understand this data. By the way, the row and column may be transposed in some data set. So that may change depending on the data set. But in this example, I would like to show you that number of experiment is the number of rows. That's the important point here. Then, then again, it is just a lot of numbers and words. There are more than 7,000 individuals, so we have more than 7,000 times 8 variables. So it's a lot of a lot of numbers, but it is not informative. So we would like to summarize the data. Especially, suppose that we are interested in health insurance coverage. This is the simplest variable because it is exactly yes or no question. So if you take health insurance coverage, you can summarize the data into a probability distribution table like this. And doing this can be done. It can be done by pivot table function in Microsoft Excel. I made another video that demonstrates how you get this table. So it is optional. I'm just demonstrating how you do this on Excel. But of course, knowing Excel skill is very important in your job. Maybe later when you get a job, of course, your employer will ask you to do something like data cleaning, basic data work. Then you may want to do something like this. Summarizing the data into probability distribution table is like a bare minimum of the Excel work, data work. So this is the probability distribution table for health insurance variable. So there are only two outcomes: yes or no, covered or not covered, and covered. Excuse me. And probability is given. This is for one variable. And if you extend the table to 2 variables, you can make it a 2 by 2 table. So not only covered and non-covered, you also have female and male. So now we extend our attention to health insurance and gender. So there are 2 by 2 matrices, and there are corresponding probabilities. Then, like here, let's think about this data set. If you just restrict the data to only 2 variables, then how many outcomes are there in this sample space? From this table, how many outcomes do you see in the sample space? Try this. I'm going to see you in the next video.